just about time for Tech Talk Tuesday. If you can see me or hear me, Ronnie and David are looking. I see y'all, Dave. Michael. Hey, Michael. Hi, GB. Frederick. Let y'all sign in here, get a few folks online, and then we'll get into the subject today. Coming in loud and clear. Thank you, Michael. Hi, David. Hi, Daryl. Glad to see all y'all signing up. Got some good goals on stuff to talk about, Eric and all you guys. I was at the track Saturday late, missed you. Okay, cool. Kelly, Scott, hi y'all. I want to talk about rods and rod ratio a little bit and some opinions I have on that. And also I'm going to talk a little bit about compression ratio, static versus dynamic. Hey, Lou. Hey, John. Pretty controversial subjects, rod length and compression ratios and static versus dynamic. So I don't care if it's controversial. I only have my opinions and what we have learned over the years. Hey, Larry, Brian. So not going to try and make anybody mad or dispel some rumors that people have based their entire career and life on, so I'm not after that. I'm just going to share opinions and ideas and experience that I've had and what has really benefited us to move forward in engine development through the years of going from carburetors, learning about carburetors and learning what's required to make a carburetor work well versus fuel injection and throttle bodies and how that affects low end power, top end power, and also along the way we talk about what we've learned on how that works with carburetors versus fuel injection and how we can tune and make it efficient. What's interesting, Joe, Frank, Asim, and Carlton, a couple of things that are interesting that's not popular because there's a lot of guys that do a lot of cool carburetor stuff and fuel injection stuff, and I have competitors that are really good at it, and we all have our opinion. We all have our opinion of what works. We have, our thoughts of, hey, Tammy, I know who Chuck is now, even though I called him Dennis once or twice, but he didn't really notice, I don't think. But it's good. It's good. It's great for you guys to listen in and let me share some experience with you. Like I said, I'm not going to try and argue or disagree with anybody, and everybody has their opinion. I'm cool with that. I am pretty hard-headed about mine, but the only way I learned is by being wrong and going after trying to prove that I was right or wrong by going through the experience and the learning process. And boy, oh boy, did I get some unreal and unusual and some unexpected results of the testing we've done over the years. And everybody, that's been in this line of work and works on, racing engines, car engines, automobile engines, airplane engines, and whatever, we all go through, I think what happened is back when, God rest his soul, Smokey Unick wrote the book back in the 60s from his racing experience and all his great works he did in the 50s and 60s, and and he wrote a book about it, and it became the Bible for engine builders and racers and customers. It became kind of like our Bible. I mean, we thought that since Smokey said it was true. Well, he was one of the most famous guys at the time and raced around the world and helped a lot of people, and he was very influential. Another one was Bill Jenkins and of course champion Warren Johnson and Bob Glidden and some of those guys, man. They really paved the way for us. And then, of course, the NASCAR guys and stuff. But, overseas and in the Formula One and some of the high-end stuff where we weren't saddled or restricted with intake, the fuel injection was really blazing a trail, while our pro stock cars were our high-end engine experience in America, and pro stock motorcycles, and then NASCAR were all Holley carburetors. I mean, in the pro stock motorcycles we ran McCoonies and Keans, and we ran some old carburetors, and we even ran electrons and all kind of cool stuff that we learned. But we designed a lot of engines, cylinder heads, camshafts, beliefs, and rules, and I call them engine rules. We created these based on experience with carburetors. And a carburetor now is a fickle thing. It takes a serious depression difference on one side to the other to make fuel come out of it. Excuse me. And a lot of times we have to port our cylinder head and design our camshafts to try and match a carburetor and a carburetor size and how much airflow goes through it. So there's a lot of rules that people try to stuff into a fuel-injected engine based on carburation. Like I said, I don't know everything, and I just have an opinion, and I've learned a lot. I know you guys get tired of this, but I'm going to qualify my experience based on, I was one of the very few fortunate ones that were able to spend decades, maybe 8, 10 years more, 12, 15 years, while I was funded by sponsorship and other projects that allowed me to come in every day and clock in and work on how to develop more power. I know there's a few people in the world that have gotten to do that, but that is definitely a blessing that I received. My day job was to find more power by next week, and my next day job was to find more power by the next day. And when you find 100 things that give you more power, eventually you're going to find 100 things that don't give you more power, and it's really hard. The pickings get slim, man. It's like the next 50 things you try, none of them make more power, so it becomes very, very tiresome, and it gets old. I mean, it really does get old. And if you can plow through that and come out on the other side, then you're going to have some great experience. Now, I see a couple people talking about how Smokey helped them and all that kind of stuff. Yes, he was the one that was working on it every day while the rest of us did our day job. Well, I was very fortunate to get into that too, and I'll never compare myself to Smokey's experience or Smokey's learning or teaching. But what we did learn is when we started racing in pro stock cars and pro stock motorcycles, we had to use a carburetor. That's the rules. NASCAR had to use a carburetor forever. Pro stock had to use a carburetor forever. And this is one of the best carburetors that was ever built for Harley Davidson. It's a S&S Super D. We used it on turbocharged Kawasaki's, turbocharged Suzuki's. We used it on everything. I mean, this is just a good carburetor. And if you can see from the outside of it, can you see the shape of it where it tapers down? It tapers down to where the fuel pickup is. And the fuel pickup is in the center of this venturi, and then it expands back out on this side. I hope you can see this okay. So what that did is when the pistons go down on the engine when it's running, the pistons go down, it creates a depression in the cylinder through the cylinder head when the intake valve opens, and then that depression would make the air come through here so fast. If it didn't have this extreme taper in here, there wouldn't be a way for the engine wouldn't ask for the fuel to come out of this little nozzle right here. Now, tuners along the way started learning that they needed to put extra fuelers in, which these Thunder Jets, these are all kind of, oops, I hit my Thunder Jets. You can put a Mikuni jet in here, and I'll put a Mikuni jet in here, and when the airspeed would get to a certain speed through this carburetor, it would draw fuel out of the bowl as an extra fueler. So you could put long ones in, good grief. You could put long tubes, short tubes, and try and catch different RPM ranges, different airspeed ranges to add fuel, because a carburetor only has the correct air-fuel ratio at 1 RPM. Everywhere before that RPM and everywhere after that RPM is not perfect. And carburetor experts may argue because their goal is to make a carburetor have the correct air-fuel ratio at every RPM, at every throttle position, and at every demand. But I'm going to tell you, carburetor doesn't do that. And let me say something right now that's going to maybe be disagreeable to some people, but it's really, really hard. We have not, at Star Racing over all these years, we have not made more horsepower, more peak horsepower with fuel injection over carburetors. Because a good carburetor, and one of my elders that taught me a lot is George Smith from S&S, and his dad, and they made these carburetors. They sandcast these at night before they even had S&S. They made these carburetors. I think they were all dairy farmers, had a farm in Wisconsin, and they were making carburetors back in the 50s and 60s, maybe before that. But they're really good. That whole company and that whole family were awesome carburetor people. They learned a lot about carburetors. And he told me a long time ago, he said a good carburetor is hard to beat. Yep. Now, we're talking about peak horsepower, okay? Now, you can change the size, you can change the shape, you can change the length, you can change the tapers, you can put more venturi, less venturi, and you can make this carburetor tune well at different RPM. But what we had wrong with using these on a street bike, our industry went to where we were looking for 150, 200 horsepower and more out of these Harley-Davidson engines, Evos, twin cams, and they came from the factory carbureted, and they had little baby carburetors on them, but they throttled so nice, and they had an accelerator pump so that when you would open this carburetor, suddenly the air drop would almost stop the air, so there would be no fuel. I mean, this thing's sitting here just idling, and it's just plugging along, going potato, 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 and then you gap this wide open, and the engine would die, cough, spit back. So the factory put an accelerator pump right here, and they also put a CV, constant velocity can on it, where it would only open a secondary throttle when the engine could stand it, so it would carburate really well. Well, when we started going fast and making big power, we had to come up with bigger carburetors, because the carburetor is the restriction on airflow, not the cylinder head, not the piston, not the cams, it's just the carburetor. If it wasn't a restriction, fuel wouldn't come out of this hole. Fuel wouldn't come out of this hole. The restriction and the airspeed across the restriction is what draws the fuel out of the bowl. Now, that's a lot of news about something old. The great news is we now have fuel injection, and we have throttle bodies. This is a stock Harley-Davidson throttle body. This is a 55 millimeter that comes on a Milwaukee 8, like a Road King or a Road Glide, 2017, 18, 19, 20. It's a 55 millimeter throttle body. This, 10 years ago, would be a racing throttle body. But the industry is starting to learn that this is not what causes bottom end problems or carburetor problems. We still try to make an engine carburate well even when it has fuel injection, and that's just a term used for giving it good street manners, good throttle control, making it drive on the street nice, or having a good personality on the street. Because everything's not a pro stocker. I know it sounds crazy, but everything's not wide open. I mean, even the guys in NASCAR, they have to come out of the pits, they have to drive out, they have to drive in and out of the garage, and they can't just hold them wide open. I know at Daytona, those guys that are going 200 miles an hour in those cars, their RPM range only changes about 100 RPM all the way around that track at Daytona, and even in the curves. So they don't have to have any real drivability issue. They don't have drivability issues other than slowing down or speeding up or coming through the gears at the green flag or at the restart. So that's an important part of the technology that fuel injection helps us with a lot. Now, this 55 millimeter stock throttle body is bigger than this S&S Super D, okay? Well, why does this make power at 1800 RPM and at 6000 RPM, whereas this won't. This will not make power at both places. This will make it down low. This will make it up high. However, we tune it to work jet-wise. Change all the jettings in it. This throttle body has no jets. All it does is move air. And it has an electric motor on it that your throttle on your motorcycle is a rheostat, like a volume knob. It goes 0 to 5, and this little motor goes 0 all the way up to full throttle based on the voltage input through this motor, and that's called drive-by-wire. And all the cars have it now, and it's just happened in my career. All that stuff every car went from carbureted, every motorcycle went from carbureted to electronic fuel injection now. And it's a wonderful thing. Now you take the B2 heads. I mean, I have some B2 intake manifolds that would put a carburetor on it. Well, the carburetor is really little compared to the new EFI, because as we grow and as we go and as we learn and as we go faster, we're still trying to get more and more air to the engine. But we can tune this by running 40 or 50 psi of fuel pressure through these injectors, and we can turn the injectors off, turn them on, make them bigger, make them flow more, make them flow less, stay on longer, stay on shorter amount of time. And at really low RPM, where the air is moving in and out of the engine really slow, we can change the throttle, the amount of fuel that goes in through these injectors. I know this is real basic information. And then when the engine gets up to full song, full power, you turn this injector up more and more as you go, and that's how we tune now. This is a B2 intake manifold with a couple nitrous nozzles, and it's a big throttle body also. And this one has all the gear hooked to it. This is a cable operated, like fits on Dynas and Softails and early bikes before 2006. And what we learned, at the bottom of the story here at the end, what I'm trying to tell you is velocity is important, but it's not the end-all be-all like it was back in the carburetor days, because the only way we could make fuel come out of the carburetor was through velocity. Now we can shorten up the cam. The more airflow we got, like the 4-valve heads now for pro stock motorcycle, for the motorcycles, and the new Milwaukee 8 have 4-valve heads, and they flow so much air that we just keep taking cam timing out. Now let me tell you about velocity with cam timing. Back in the carburetor days, and we were going to make power at 7,000 RPM with this big carburetor, we would open the valve way early, like 30 degrees before top dead center, and then we would close the valve really late, like 70 degrees after bottom. So that whole time that valve is open, that's so that we could get enough air through this little hole. Nowadays, we got these big throttle bodies. We run 70 millimeter on these now, a 70 millimeter. And our Pro Stock, S&S Pro Stocker, had two 3.5 inch throttle bodies, two of them, 3.5 inches per, what was that, 84 millimeters per cylinder. 55 for both cylinders. I'm talking about 84 millimeters for each cylinder. And that made so much low-end power because airflow and cam timing. And also the tunability of the EFI system, where we can take these injectors right here. You see this hose right here comes out of the gas tank? You run 40 or 50 PSI through this to this fuel rail, and then these electric little valves right here, they spray the fuel in and out of the engine. They spray the fuel in the engine when we tell it to with the computer. The cool part about that is we've learned that we can make more power and more airflow without worrying about velocity. And every time you put a bigger throttle body, a bigger manifold, bigger valves, bigger ports, you lose velocity overall. But when the piston's going the fastest, which is another whole story about stroke, piston speed, bore, and creating a depression in the cylinder to where the air rushes into the engine. And I use this as a benchmark for us. If you took the cylinder head off of your engine and you rotate it from TDC to the bottom with the cylinder head off, it was 100% full of air from even at rotating with a wrench. You turn the crankshaft and the piston goes to the bottom. It fills up 100% with atmosphere, 100%. Put the cylinder head on, put a valve in it, put a camshaft opening and closing the valve, put a rocker arm to accelerate the movement of the valve, you're restricted now on how much air will go in the engine based on the cylinder head, the valve, and when the valve opens and when it closes. With no cylinder head, there is no restriction. So that's a good benchmark to think about right there. No cylinder head has all the flow you need. Problem is you can't compress it, you can't light it, you can't make power out of it, and you can't exhaust it out because the cylinder head is just the windows that open and close to let the air in, close them all, squeeze it tight, light it off with ignition, and then it goes bang, turns the crankshaft really hard, and then you can open the window to let the exhaust out. So that's what the 4 strokes of the engine are. The problem we've got is over the years and decades, we have painted ourselves into a corner of where we think the velocity is so important that we restrict our throttle bodies, we restrict our port size, our valve size, trying to maintain some velocity that we can measure on a flow bench. And a flow bench is just a tool. Like it just gives you a number based on the parameters you put in it. How far do you open the valve? What depression are you pulling on the other side of the bench? Like when your piston goes down in your engine at 7,000 RPM, what is that depression? Well, I promise you it's not 10 inches of flow bench or 25 inches or 20 or not 28 inches or 50 inches. And if you got a Superflow 300, 600, or 800, or 1020, none of those flow benches flow enough air to simulate what the engine is asking for when the intake valve opens and the piston goes down enough. It is a big, big number. It is way higher than a flow bench. So flow bench is a cool tool. It's neat. And the part for me that worries me, not worries me, but it's a little bit aggravating is people call me up all the time and they decide whether they're going to do work with us based on cylinder head airflow. So I'm like, they say, "Hey George, how much does your head's flow?" And I'm like, "Okay, what do you want it to flow?" And they said, "Well, I want it to flow a lot." And I said, "Okay, well, what's the number you want?" I mean, I'm telling you, I've already been through this before, but 400, is that big enough? 350, 300, what do you want it to flow? Well, they read. Yeah, they read. That's it. But it's not relative to anything that's really happening. The scoreboard at the end of the racetrack, the time slip that tells you how fast you went, the dyno sheet, and also when you're riding a motorcycle and you're going along and you're going through the gears and you're feeling how fast it is, think about it. That G-force, that acceleration, that's what matters to you, not how much the head flows. Okay, world record cylinder heads. We won races. We set records all over the world. Yes, those heads flow a lot of air. Yes, they do. They flow a lot of air. Now, how much air flow and through an engine? Well, think about this snapshot right here, y'all. The piston's at the top. Crankshaft turns over, and the rod rolls over, and the rod ratio and the stroke pulls the piston down. At peak piston speed, which is 77 degrees after TDC, the draw on the cylinder head, which is the flow across the intake valve, is more than anyone's ever dreamed in that snapshot in time. At idle, it's a lot of flow. At 10,000 RPM or 14,000 RPM or wherever we're running our engines now, listen to me, that is a number that a flow bench could never match. So we have to be, don't get married to your flow bench thinking that that's just going to give you the answer. It's going to have to make power at all RPM, at the RPM you want it to, and at the and in the range you're going to run it. Okay, I'm running out of time pretty fast, so I'm going to try and talk for a minute about a connecting rod deal. Here's some Corello rods. Okay, it's pretty neat. This is the knife and fork Harley style. This is a really old display we had. I think this is like a Hayabusa rod, or the same as like a Chevy or a Ford or a Chrysler rod. What's neat about this one here is the cylinders are in line. They're not offset like a Chevrolet or a Ford. A Chevrolet or a Ford, if you know this, but one bank is forward and the other bank is backwards. And the reason it is so the rods can fit side by side. The left side and the right side have rods side by side. Harley-Davidson has inline cylinders, so the rods have to be parallel. The pistons have to be parallel with each other. And for our use in engine building is we design the ring package first. We put the biggest bore we can get, and then the cubic inch limit is set by the stroke. Think about that order. Ring package first. Make sure the rings are there, because nothing matters. It don't matter how much your heads flow, how big your valves are. It doesn't matter how big your cam is. It doesn't matter anything if your ring package and your bore and hone job and your piston is not good enough to contain or hold that much pressure when you pull in a bunch of air through the depression, through the cylinder, compress it, light it, and expand it, and it goes boom. And when it goes boom, if it leaks by the rings, I don't care if you got the best flowing cylinder heads in the world. You got to seal it up, you got to contain it, and you got to be able to use it, okay? So first thing we do is a good ring package, a good cylinder package, and a good piston. Next thing we do is we identify the cubic inch limitation, and then we put the biggest bore will fit. Stud pattern, base gasket, head gasket, bore centers on the Chevrolet or the Ford, a 4.840 or a 4.900 or a 5-inch bore space V8 or Hemi, or a 5.3 Mountain Motor Pro Stocker, might be a 5.3, and you put the biggest bore that will fit, and then the cubic inch rule says what the stroke is. So if they got a rule that says 600 cubes or 700 cubes or 800 cubes, you still put the biggest bore will fit, and then you stroke it to make the cubic inches. Bore first, stroke second. Then the connecting rod is just, it's a silly thing, but it's once you put the stroke in, once you put the bore in, the connecting rod is how you connect the dots. It might be 5 inches, 6 inches, 7 inches, 8 inches. It's going to be whatever it's going to be. And there's a lot of reasons why the rod has to be the length it does. On a Harley, the pistons hit each other at the bottom. So you have to put longer rods in it so the pistons can hit each other when the bore is big enough. Also, if your deck height on your block is really tall, you're going to have to put tall, long rods in it, but not at the expense of the ring package. Understand me. But the rod ratio is going to be the rod ratio, and this is where a lot of people are going to disagree with me. If it's 1.5 to 1 or 2 to 1, somewhere in that range is okay, because people say, well, yeah, but this was Smokey's big secret, was having a longer rod does this and a shorter rod does this, but those are the insignificant things that, and when I say that, it's not true. They are low on the totem pole. They are on if I did my top 10 importance in an engine design, connecting rod length is absolutely last place. It has to be long enough for the ring package to be good, and it has to be long enough where the pistons can't hit each other, and that's it. So I'm sorry that that might interfere with some people's belief. But look, thank you all so much for the time. It looks like I'm about out. Happy Thanksgiving. A couple things I want to share with you guys. The Man Cup this weekend was outstanding. There was 800 to 1,000 motorcycles in it over a 3-day event. The weather was scary on Saturday evening, and it got too cold on Sunday, and they had to keep running on Monday, and a lot of people got mad. And in reality, it doesn't matter who got mad. The ones that ran got mad, the ones that didn't run got mad, and the ones that lost got mad, and the ones that finally won were mad because they had to stay there too long, so everybody was mad. But look, none of us are big enough, smart enough, or better enough for us to control the weather. The good Lord supplied the atmosphere and the oxygen and the weather that was so beautiful. Yes, it rained and brought in a cold front, and the cold front messed up to where it was hard to get traction with 1,000 horsepower, 400, 600 horsepower motorcycles. Never seen that many motorcycles in one place that could go that fast. They're going to have to start probably a day earlier next year, and people have to be ready to stay an extra day if they have to. But you can't get that many people down the track that many times with the track being as great as it was. Listen to me. SGMP did a great job creating world record track conditions. The good Lord, Mother Nature, put together a package that made a lot of power, and then our racers, the preparation and the performance that was provided by the racers was outstanding. People from all over the world came. 34 bikes from Aruba. European people came, Australian people came, and then tons and tons of Americans. So I was great. It was the 43rd annual Motorcycle Nationals for the end of the year. And last thing I want to share is bagger racing is growing really big. They made a really nice effort to promote that for us. We were able to run Bagzilla on our Star Racing bike, and Mark Frick ran his, and we had a good match race, and then he ran it in Street Fighter after that, and his engine broke, and we don't know what broke yet, but he ran in his oil and he fell, and it took an hour or so to clean that up, so that messed up some folks. But he's okay. The motorcycle can be repaired. His safety gear was awesome. That's a subject for another time, and I am running out of time, so I want to say, Happy birthday to Star Racing. 40 years yesterday we've been in business. Hard to imagine, 40 years since Jackie Bryce and I came in as little motorcycle sportsman guys, and we wanted to make a business and help people make their motorcycles go first, and we were able to go fast, and we were able to do it. I'm very thankful for that, for the good Lord. Y'all, please be thankful. I know every country and everybody watching doesn't have Thanksgiving like we do in America, but you can also give thanks every day, because we have it made compared to the people that can't watch this and don't watch this, and we have it made. So thank y'all very much. Please be thankful. Take care of each other. We're all we got. May God bless. Happy Thanksgiving.